Yeah.
I had Gary Kleibin for that. I don't know if he's still teaching here. I think that was his name. He's pretty good.
Mm.
So what kind of classes are you guys taking this semester? Just kind of to give me some context. Are you doing physics 225, obviously this class, and are you in Calc 2 now or Calc 3 or?
Calc 2, yeah. I took Calc 2 over the summer, but I failed it, so I have to
Hmm.
retake it.
Calc 2 is pretty tough.
Yeah. Well, my teacher didn't teach, he didn't do a lecture at all. He would just tell us to do problems from the book and do examples from the book, and that was pretty much it.
Hmm. Yeah, that's going to be pretty tough then.
But the teacher I have here for Calc 2, he's pretty chill.
Hmm.
He actually teaches.
That's good. Who do you have for that?
George Arthur.
Okay. Is it him that wrote a book for Calc, or is it some other professor?
I have no idea. I just heard from my SI leader last year that he was really good with Calc 2.
Oh, okay. Yeah, essay is good. That's good that they have some of that. I know they have some for some engineering classes too, but there's not as many.
Yeah.
All right, so we're gonna wait a bit more. Only got 26 people in here so far.
I have a quick question.
Mm-hmm.
So I was reading yesterday about about like the commands and everything. So when I type it into the workspace or let's say if I want to clear something and if I type it into the workspace, will it clear everything, or would that have to be through the command window?
Um, you have to do it through the command window.
Okay.
So we're actually gonna go over that today too, on how to clear variables and stuff like that.
Oh, okay, thank you.
Mm-hmm. So yeah, hopefully all of you got MATLAB installed before today. So if you did get it installed, you can open that up because basically what my plan is that I'll go over MATLAB today. I'm going to go over some of the commands and whatnot, and hopefully all of you can follow along. We'll try to do it like that.
Yeah. I
Yes, sir.
ordered it.
Someone have a
Yes, sir.
question?
Yeah,
Mm-hmm.
did you get that email that I sent you for the opt off, the opt on thing about the ebook?
Oh, okay. I didn't know that was an email. I didn't get that email, but yeah, I can
Uh,
talk about that.
because I mean, I asked because the another gentleman in my fluids class brought it up, and which I didn't know about until you
Mm.
told me about it.
Yeah. Yeah, I didn't know about that either until basically the first day. So
Okay.
yeah, I'll talk about that. Seems kind of, I don't know, pretty messed up.
Yeah, I feel like it's weird they didn't do that last year.
No.
Yeah, yeah. If you have 2019A, that should be okay. Yeah. I would actually assume all of basically the commands in there, they're going to be the same in this version probably in 2028. There might be some very slight differences in the program, but probably all of the commands are going to be the same. Usually they don't change the commands much. You want to keep them pretty stable throughout or pretty consistent. Okay. So, looks like we got 40 people in here now, so pretty much everyone's in. So if you guys have MATLAB installed by today, then make sure to open it up now. And basically for this class, I'll have slides open because I'm gonna basically try to go along with that, but I'm gonna be in MATLAB myself, and all of you can follow along. But basically, if you want to look at the slides too, if you have you can pull it up on your phone or something, or maybe you want to have a split screen on your monitor, whatever method works best for you. But I would recommend having MATLAB open, and obviously you're going to want to see what I'm doing too. So if you can get the Zoom lecture open up somewhere, whether that's on your phone or on your computer too, then try to do that. All right, so I'm just going to give you some time to open it up if you don't have it open yet. And then I also saw that some of you were having trouble installing MATLAB, so if you weren't able to install it because you ran into some issue, then you can stay in class after it ends and then I can help you out. Although if it's like a more complex issue that I can't help you with, in a reasonable amount of time, then I'll have you just go to the IT department basically, and they should be able to help you better than I can. And also the audio should be a lot better today too. You shouldn't have to turn it up too much. Okay, so first thing I'm going to go over really quick is the course website again. So I'm going to go on the home page, and so I added some stuff onto my YouTube channel. So I added the lecture for the first class. So if you go to the channel, you're going to see I have a playlist for this semester just right at the top. So for our class, you're just right here. So I'll add all of the lectures there. And then kind of like I talked about last time, I might make some, I don't want to say random videos, but they're random videos to the class. You don't need to have them, but I'll make some general videos that I think will be helpful for all of you. So stuff like law tech or something like that, I'll put in this general playlist right here. So if I click on week 1 on the homepage, you see I added the videos there yesterday as well. So I'm going to keep doing that. So today I'll add the lecture or the link to the lecture down here. You see, so I'm doing season 1, episode 1. That was yesterday. So I don't know. I just did that like each week is a season and each class in that week is an episode. So if you were confused by that, that's why. And so today I wanted to make sure that all of you have MATLAB installed. And then videos are up on Canvas like I just talked about. And today we're going to get started on the basics in MATLAB. So I have these slides, so I never taught this class before. I only taught labs before. I taught 306A and 306B. So for those classes, if I had a lecture, I would do the lecture, but basically I had 3 hours to do it, and it never took that long to do. So for this class, though, I want to try to take up the entire time so I can help all of you, but it's hard to kind of plan for that time right now. Like, I don't know how much we're going to get done today. So there might be some adjustment going on. The slides I updated earlier today. So if you already downloaded them, you might want to download these slides because they're more up to date. I basically added some more stuff and kind of changed the layout a bit. So yeah, just make sure you have those if you want them. But either way, you can just follow along with what I'm doing on the screen because I'm going to go off these slides myself. And I'm actually going to have them pulled up on my screen too. Okay, and then quick random question. I was testing out this mic last night, because I just got something new that will help the audio be louder. And it was clipping sometimes. So I just want to make sure that it's not clipping today. So just, I don't know, put it in the chat or something if it's clipping. Not yet. Okay, that's good. Okay, cool. Okay, so I'm gonna go into MATLAB now. I'll change the colors again. I'm gonna put everything to the default just so it looks more familiar to you. Okay, so I'm gonna put the slides on my screen like this.
I'm sorry, Professor, quick question. How do I get my workspace tab to come out? Because I don't have a workspace tab on my right side.
Okay, so for that, you should be able to go to layout here in the home tab. Do you see that on your screen?
Not yet. Sorry, let me just.
It's okay. But yeah, if you go there, it should be on the home tab. You can click on layout, and then you should be able to, if you see right here where it says show workspace, you should have a check mark there. Or you can click default, and then by default the layout should have the workspace as well. But we're mostly gonna live in the command window today anyway, so if you can't get it to show up, when you just change the layout, you can come to me after class too. Okay, so now we're gonna get started. Did you get it? Okay. So we already went over what we're gonna do in the class last time. Okay, so this is the first slide, so the main window. So this is what we have inside of MATLAB. Make it a little smaller. Okay, so what we have here is the screen in the center. That's going to be the command window. So I'm going to go over some of the stuff. I'm going to go over again some of the stuff that I went over last time. I'm going to go in a little more depth today. So this main window, this is the command window. For the beginning of the class, probably for the first few weeks, we're going to pretty much stay in this command window. So we can write a command, and it's going to show some output in the command window, but it's not really going to be saved. So, if you type in the command window x equals 5, then you press enter, then you're going to see that output in the command window right below. So we basically assigned a value to this variable x, 5. So if we were going to close out of MATLAB, it wouldn't be saved in our workspace over here on the right. It would go away. So later on, once we start writing programs, we're going to use a script file. So we can save that file, and then we'll load it up again. We're going to run that script, and then all of our variables, they're going to show up again in the workspace. So really the command window, I mean, it's useful, but once we start doing, I guess, more involved stuff, we're going to write scripts, so we don't need to worry about our variables disappearing, once we come back to it a day later or something like that. Okay, so I'm just going to talk about the layout first. So this is the command window in the center. That's where it should be on your screen. It might be different, like you could change the layout. So if I click on 2-column, so the workspace went over here now, but I'm going to keep it on default just because that's what I'm used to, and that's probably what you have to. Okay, so then on the left, we have the current window. So right now, it's actually just at my home directory because I didn't change the folder. But I'm just going to go to what I made for the class. So we're not going to do this right now, but I just want to kind of show you. So if I open up a script, so I'm opening up this debugging script, and again, the .m file, .m is for a script file. So I opened that up just through MATLAB. And then if I click run up here under the editor tab, click run, then that ran, and now my folder is going to be changed to right here. Sometimes if you run a file and you didn't already change the folder in MATLAB, if you click run, MATLAB will have a prompt that will say, do you want to change the folder to this directory? And you just say, yeah. But anyways, that's a little down the line. So again, left side, we have the current folder. And then you can also see the path up here, right below this top toolbar. You can see where you currently are. Okay. And then on the right-hand side, we have the workspace. So I've had a few questions about that, but the workspace is basically where we have variables that are going to be stored. So I'm going to clear that. I'm going to talk about clearing stuff later on as well. But if I do x equals 5 again, and I press enter, then now in the workspace on the right here, we have the variable x equals 5. So the workspace will show all of the variables that we currently have stored in the memory. So if I do y equals 2, then now that's also going to show up in the workspace. And something we can do, by the way, when I keep looking over to the left, I'm looking if there's any comments in the chat. So For the workspace, if I click on one of these variables, double click on one, then that's going to open up basically like an expanded view for the workspace. It's going to open that up in the main tab here. So it's in its own window. You see the command window is still, it's now below. It's on the bottom of the screen. So let me close out of here. And I'll just show you this again. So right now we have the command window in the center and then the workspace on the right. If I double click on this variable x, and it's going to open up this window here. So we see x right here, that's the variable. And then all the values inside that are stored in that variable. So we have x equals 5. And you see in this case, the variable x is just a 1-by-1 array or double as they call it. So we'll talk about all of that jargon later on too. Once we start getting into arrays, which we might get to today, I'm not really sure again for how the time is going to work out. Now, if I double click on y, you see that now I see the output of y in this bigger window here. And I also still have a tab for the variable x. So I can click on x or I can click on y and I can see their respective value. So this will be useful once we actually start making, like if we have a really long row vector or a column vector or a big matrix, we can, you want to see all of that output in the workspace here, but if you want to see it, you could double click on them and you can see them like the entire output in this window here. It's pretty convenient. So, so far, are there any questions? Okay. So if any of you do have questions throughout, either just use your mic or go in the chat. I'm going to try to look over pretty often. I want to be sure to go pretty slow so all of you can understand, the bare fundamentals of the class. Okay, so another thing that we can do, so I have the workspace over here, x and y. So if I just typed in x in the command window, since I already have that variable stored in the workspace, if I just type x, it's going to show me what the output is for that variable. So if I type in z now, you see it says unrecognized function or variable z. So I didn't define any value for this variable z yet, so it says it's trying to look for this variable z as if I've already defined it, but I haven't. So it's saying, hey, you didn't define this yet. I don't know what this is. So you need to make
I
sure.
have a question.
Yeah.
How did you clear all the previous inputs?
I did just CLC. So that's just clearing the display here in the command window. It's not clearing it from the memory. So I was planning on talking about that a little bit later, but it's pretty relevant now. So you see here, if I don't know, let's just type in x and y again. So if I type CLC, it's going to clear everything that's in the command window right now. So that's cleared. But on the workspace on the right, it still has x and y stored in the memory. So if we want to get rid of those variables from the memory, we type in clear. Then if I press enter, then it's going to clear it from the memory. Now if I want to clear this text again, I just do CLC. So that's something I'm probably going to do pretty often just because I like having a clear command window pretty often. I'll just type CLC though. Okay, so like I was saying, you want to make sure that basically if you're typing out some variable in the command window, if you want to see its output, you need to already have it defined previously. If we have a lot of variables in the workspace, what you can also do, so I'm going to clear this again. So if you have a lot of variables in the workspace and you just want to see a list of all of the things that you have, you type in who in the command window, press enter, and then it's going to show all of the variables that you currently have stored. So for us right now, we just have x and y stored. So it's going to say you have x and y.
Yeah, excuse me, Professor.
Mm-hmm.
Is there a place to see the coding library?
What do you mean by that?
So you have all these like set things, right? Like CLC to clear the window and clear for the whole
Mm,
thing.
yeah, okay.
Is there a library for all that stuff? And it just has all the commands?
Yeah, I would just look at the documentation for MATLAB. So if you, I'll go to Google right now. So I'll just do something like MATLAB documentation. I think they call it MATLAB help though. Okay, so if you go to get started, you can see some of the commands there. I mean, there are so many commands. They're not just gonna have one page for it, but you can also just search a command. So we'll probably talk about that later too, but so you can do stuff like that. I would go to the documentation though, but again, there's, you know, thousands and thousands and thousands of commands. So there's not just going to be one page. And then also inside of MATLAB, if you click on help here, it's also going to bring, it's basically going to bring up the documentation there. Or if you type in some command that you think you want to use, like OneSpace, then it's going to bring up this dialog box where it shows you the options that you have for that command, and then you can press more help, and it'll basically open up this screen right here, and then you can read about it there.
Okay, awesome. Thank you.
Mm-hmm. Okay. Any other questions so far? Okay. So the editor window, so this is to make a script. So I'm just going to bring this up now, just so you know what it is, but we're not going to write a script until later on. But if we want to write a script, we just go in the top left here, and we click on New Script, and that's going to open up this editor window right here. So the command window, it's staying on our screen, and it's just below the editor window. Okay, so again, we're not going to actually use that right now though, so I'm going to close out of it. And when we save a script, again, it's going to be saved as a .m file. So we can save a script, but we can't save, you know, like a command window script. It's not a thing. Yeah, so to delete just one specific variable, we can do something like clear x. And now you see on the workspace, x is now cleared from the memory. Okay, so now we'll talk about suppressing stuff. Okay, so I'm gonna just clear everything again. So if you want to write a comment, and this will be more useful when we make a script, but if you want to write a comment, you put in a %, and then I'll just put this as a comment. So now if I press enter, MATLAB doesn't do anything on that line. It basically ignores it because I put a %. And you'll see that that text is now in green. So because I have a %, MATLAB, it's not trying to define that text as a variable. So if you're writing a script and you want to basically be helpful to yourself and someone else that's going to look at the script, you can use a % to basically show what you're doing in that step in the script. So let me go forward. Yeah, so this is the slide. Okay, so another thing, if we don't want to have a comment either before or after a line of code, we can do that too. So if I do x equals 5 again, something like that, I can use a % after that variable that I just defined, and I can say, I don't know, this is another comment. I can press enter, and now x equals 5, that's defined, but the comment, I can still write the comment and that's fine. So it's gonna, MATLAB will try to, it'll look at this line and it will still define x equals 5, but everything after that % it's going to ignore. Okay. All right, so basic math. So for the most part, doing math in MATLAB is pretty much how you would expect it to work. So we can do 2 plus 3. You'd expect 5. So it's going to do 2 plus 3. It's going to run that, and then it has ANS equals 5. So ANS, that just means answer. So answer equals 5. 8 minus 4, 4, as we would expect. 4 times 4, 16. And then we do, I don't know, 9 divided by 3. So to do division, as we normally think of division, we're going to use a forward slash. So 9 divided by 3, answer equals 3. Okay. So there's also something called left division, which we're going to talk about later. So that's using a backslash, but we're going to be using that to solve linear systems of equations. So we're not going to discuss that right now. We'll discuss it later on once we go into an intro for linear algebra. So for all of this, it's pretty, similar as to what you'd expect. Okay, so suppressing output. I'm going to clear everything right here. So here I'm going to write z equals 3. So if I wrote just z equals 3, it's going to give us the output right below as we've seen so far in the class. If I do w equals 2 and then I put a semicolon, so maybe, I'm writing out a lot of, or I'm defining a lot of variables, but I don't want to see the output right below each time I know what the output is, or I can check the workspace for it. I can put a semicolon. So if I do w equals 2, and then I put a semicolon, and then I press enter, it's not going to display the output right below. But if you see on the workspace, w, it just showed up right there. And we have w equals 2. So again, I can double click on it, and then that's going to open up this window here to define the variable w. Okay, so yeah, someone just put in the chat again that to clear just one variable, you do clear and then that specific variable. So yeah. So I'll just show that again too. If I want to clear w, which I just made, I'll do clear and then w. So if I run that, then w just went away from the workspace. You can still see I have w equals 2 in the command window, but that's basically stored in history now. That text is still there, but the actual variable was cleared from the memory. I can also do something like clear x, y, and make sure you have a space in between. If I didn't have a space, it actually didn't do anything. So it didn't give me an error either, but I still have x and I still have y. I'll do x space y, run that, and then both x and y, they were cleared from the workspace. Okay, so I'll just do w equals 4, put a semicolon, and then again, there's no output displayed on the command window, but it is in the workspace over here. All right, any questions so far? And if I'm going too fast, or I guess if I'm going too slow, let me know too. So, yeah.
So if there's no output, why even, add that to the script, like w is 4?
The semicolon? So when I say there's no output, I just mean that there's no output being displayed in the command window. There still is an output in the workspace. It's still stored in the memory. So if I type now q equals 2 and I put a semicolon, over here on the workspace, there's no q yet. But if I put q equals 2, semicolon, and press enter, then it shows up in the workspace. So now q, that variable, it's assigned and it's stored in the memory. It's just not basically cluttering up our screen here in the command window. We're keeping it, a bit tidy.
Oh, okay. Thank you.
Mm-hmm. So yeah, this is something that you're actually going to do quite often. I mean, a lot of the times you don't want to see that output displayed as text because you just assigned it. You don't need to see it. And later on, so I'll just show this really quick here. So we're going to talk about this once we discuss arrays, but right now I'm going to make basically a row vector starting at 0 and it's going to the number 10. And the intervals in between those two numbers are 0.01. So watch this. If I don't suppress this output and I press enter, now I have 1001 columns displayed in the command window. I mean, no one wants to see that. So in that case, we'll suppress that comment. We'll put a semicolon. And if we press enter, then you don't have to see all of that. But if you did want to see it, then you can go to the workspace, double click on X, and then you can see that entire output. Likewise, you can press X again in the command window and press enter. And now it's going to show that output, displayed as text. Okay. Okay, so we've already learned some of this stuff right now. We've actually gone over almost all of it. But we can also type who, so who with an S. Now if I press enter, we're going to get a more descriptive, description of all of the variables that we have. So A and S, answer, that's a 1x1 array. So remember, we're actually going to talk about answer in a bit, so I'll just leave that alone right now. Q, that's a 1x1, and bytes, that's just the size of the actual variable, so the memory that's being used. W, that's a 1x1 array. X, that's a 1x1001 row vector that we defined. Remember, that's when I did this, and actually it was 0.01. So don't worry about that right now. We're gonna discuss how to make arrays later on. And then Z, that's 1x1 as well. So I'm gonna clear everything now. So remember, now that I'm typing clear, it's going to remove all of the variables from the memory. So the workspace is going to be absolutely wiped. Press clear, press enter, type clear and then press enter. Now, I still have this text here. So again, that's just text. It's not anything these variables don't exist anymore. So if I type Z, it's not stored anymore. So I get that error. So now I'll just clear through CLC. That's going to clear all of the text. All right, and then we already went over clear variable 1. So if I have x equals 3 and y equals 7, if I only want to clear x from the memory, I type clear x. So var 1, that just means, it's an example, just variable 1. So I'll do clear x. X is now wiped from the memory. No, if you clear the workspace, you can't recover it. Well, I guess you can in a kind of a roundabout way. So I was going to talk about this as well, I think, at some point. But basically, if you're in the command window right now, so I just cleared the variable x. If you're in the command window, so do this as well right now, just so you know how to do it. If I press the up arrow on my keyboard, it shows our history for what we typed in the command window. So it's showing the history, but so it's showing like x equals 3 here, but that doesn't actually exist as a variable. So again, it still exists as text in the memory, but that variable x doesn't exist anymore. You can see on the right, x isn't there. And if I typed in x, it's not there. But if I press that up arrow, I can access all of the commands that I've written. It's actually quite a lot. If I kept going and kept going, there would be a ton of commands. So that's just stuff that I've worked on for a while. So if I go up to x equals 3, we can kind of do it in this roundabout way, so I can press enter, and then I would basically have to redefine it. So it's not really a way to recover everything, because you would have to do that line by line. And if you wrote something a long time ago, you can't just recover all of that workspace at once, basically. So I guess this is technically a way to recover the workspace, but it's not really, there's not really a true way to do that. So hopefully that made sense, but yeah, this is just a roundabout way to do that. Okay, any questions? Any other questions? So we're going to talk about the ANS variable, or the answer variable. So I'm going to clear everything that I have here now. So I'm going to wipe everything from the memory, and then I will clear all of the text. Okay, so if I do just some basic math operation like 2 plus 2, and I'm not going to suppress this output, so I'm just going to do 2 plus 2, and then the output that we get is ANS equals 4. So it displays ANS equals 4 in the command window, and then we also now have the variable ANS that's now defined where ANS equals 4. So answer, or ANS, I'm just going to call it answer. So answer is now a variable in MATLAB. So I can type ANS here, and then I see that output, yeah, it's ANS equals 4. If I do 3 plus 2 now ANS equals 5. So I just overwrote that variable. So answer no longer equals 4, and now equals 5, because I just had a new math operation. If I do 4 plus 4 now, answer now equals 8. So answer is a variable, but whenever we have some new math operation and we didn't assign a variable to that math operation, answer is going to be overwritten. So if I keep doing, basic math operations, it's going to be overwritten. So a way to avoid that is that now I can do something like x equals 9 plus 2. Now x is defined, so x equals 11, and then answer, that's still kept in the memory as 8. Again, then we can use answer as an operation itself, or really I should say it can be used in an operation. So let's clear all the text. So answer is still stored as 8. So I can do ANS plus 2. So I guess we can actually do a bit of an exercise here. It's kind of given away in the slide, but in the chat right now. So I'm going to type in answer, and then I'll do ANS plus 2. So in the chat, put what you think ANS plus 2 is going to be outputted as. What's the value that's going to come on the screen? What's the new value of answer? What's that going to be? Okay, yeah, 10. Okay. Yep. Okay, so pretty basic, but good. Okay, so yeah, we can use answer in an operation itself. And then I could have done something like y equals ANS plus 3, and now y, that's going to be 13. Okay, any questions? Seems like you're all getting it pretty well so far. Because I want to go slow so we can really build a good foundation. Okay, so I'm going to clear everything. So as you can imagine, it's not going to be good practice to use answer as a variable, because that's going to be rewritten very often if we don't assign a variable for some operation that we do in MATLAB. So really what you should be doing is assigning a variable to whatever operation, or so like math operation, or just the value that you're making, or maybe you're making an array, which again we'll talk about later. So it's better to assign a variable directly yourself. And then yeah, so you can continue to reference these variables. And so I put until we exit MATLAB, and it's not saved if we're not using a script. So kind of like one of you brought up earlier about restoring the workspace. There is that roundabout way where you can technically restore the workspace by pressing up on your keyboard, the up arrow. You can access all of your text history, and then you can redefine a variable. So the same thing here. If I type in this bullet point here, I say you can continue to reference these variables that you assign until we exit MATLAB. It's not saved if you're not using a script. So I should put a little star there, because in practice, that is true. I mean, so I'll show you what I mean though. If I type in x equals 100 right now, so I have that output. Now I'm going to close out of MATLAB, okay? So I'm just in the command window. I put x equals 100, x equals 100. That's in the workspace. I'm going to close out of MATLAB. I'm going to open it back up. So now here I am again in MATLAB. X equals 100. That's not in the workspace anymore. It's gone. So that's what I mean when I say that they're not saved in MATLAB. But again, we'll talk about this. I'm going to use in quotes here this roundabout way to recover that workspace by pressing up on the keyboard, the up arrow, and I see x equals 100. So basically what I'm doing is redefining this variable. My entire session isn't really saved, but I can, again, in quotes, recover it by going up on the keyboard, but that's not going to be efficient at all. So that's why we use the script. Okay, so clear it. Okay, so we'll just go through this exercise. You know, bananas and peanut butter, yeah, they're pretty great. So we'll do banana equals 20. We're going to suppress that text output. So banana, that's now assigned to the value 20. We see in the workspace, banana, that's equal to 20. Okay. PV, now I want a banana and peanut butter sandwich. Okay, PV equals 10. So now we have PV equals 10 and banana equals 20. I'm going to close out of this. So now those variables, they're stored, so, and then we can use them, right? So we'll type in yum, because, yeah, it's pretty good. Yum equals banana plus PV. So since we stored a value, you know, or we defined each of these variables, banana and PV, we can use them in operations. So now I'm doing yum equals banana plus PV. If I press enter, we see the text output here. Yum equals 30, so just 20 plus 10. And yum, that's now defined on the workspace, yum equals 30. Okay, so we were basically doing this earlier, right? When we were doing our basic math, like 3 plus 4, that's 7. Except now we're assigning a variable to each of these values. So in this case, banana equals 20 and PV equals 10. And then yum equals banana plus PV. Okay, overriding a variable. So we kind of already saw that with answer. So we overrode the variable answer. So if I did 4 plus 2 now, instead of answer equals 7, answer is going to equal 6. So we can do the same thing with variables that we already defined ourselves. So if I type in yum equals 30, we just did that. That was yum equals, we'll go back, banana plus PV. And, you know, I had different numbers in the slides, but for us, we had banana equals 20. You see it in the workspace, and PV equals 10. So 20 plus 10 equals 30. Yum equals 30. If I wanted to write over this now, if I want to make yum something else, I could do yum equals, I don't know, banana plus 500. Now yum, that's overwritten to 520. So yum no longer equals 30 and now equals 520. So I think that's pretty straightforward, but we're not going to get any error or anything like that. We can reassign a value to a variable. Okay, arithmetic operations. So for the most part, we covered all of this already. So this is a screenshot from the book. So if you have the book or the PDF, it's table 1.1-1. This is from the 3rd edition. And I think that's what was shared in Discord. Not that I officially saw that, but yeah. Okay, so we covered multiplication. So that's with the stars. So like they have there, it's A times B. So 3 times 2, 6. Division, 9 divided by 3. Oh, also, I guess I should bring this up too. So I have a space before the / and after the backslash. I can also do I don't know, let's do 10 divided by 2. So if I do 10 divided by 2 without any spaces, that's still going to work. So I'll often put a space in between math operators just to make it easier for me to read. I think that's a good practice. And then addition and subtraction, they work as you would expect as well. So the only thing we didn't cover was having an exponent. So if I did 10 squared, so we're going to use the caret. Pretty sure that's what it's called, the caret. So 10 squared, answer equals 100. So as you would expect. And I talked about this earlier, but the backslash, so that's a left division operator, and that's going to be used to solve linear algebra equations, so like a system of equations. And I guess I kind of want to put some, context to that. You will be, a lot of your work for, your career or something like that, you're going to be solving or using linear algebra. So we're going to have to solve linear systems of equations pretty often. I just did it for myself last semester, like doing something like this. I took EGME 417. So that's a computational heat transfer class. So something you do in there, and you actually use MATLAB in that class too. So you write some code to, in this case, it was to solve the heat equation. I know you guys haven't gotten to like heat transfer yet, but we were solving that, and basically we were using linear algebra as well. So we would have to solve a linear system of equations. So you would use that backslash to do something like this. So anyways, I just want to give some context, I guess. Okay, any questions so far? Okay. All right, so operator precedence. So just like with, when you learned math in, I don't know, like 6th grade or something, middle school, when you learned the order of precedence, we have that in MATLAB as well. Okay, so here are all the rules. So MATLAB will evaluate something that's in parentheses first, starting with the innermost pair, and it's going to go to exponentiation next from left to right. And we're going to have multiplication and division. Those are equal precedence, so then it's going to go from left to right. And then we have addition and subtraction, equal precedence between the two, and that's going to be evaluated from left to right. So you can either remember that, or you can use parentheses, and that's going to help with readability as well. So for our example here, so hopefully, by the way, you guys can see the slides okay. If you have a small monitor, it might be a little small, but hopefully you can still read it okay. So for this example, we're doing 5x squared. So we have a fraction basically. So 5x squared, that's on top. And then on bottom, I want to make sure that I can easily show that all of this line has to be in the bottom of the fraction, so in the denominator. So 3 plus a plus b plus c, all of that needs to be in the bottom. So I've enclosed that entire line in parentheses. But then I also have 3 plus a, that's its own kind of grouping by itself. So I enclosed that in parentheses. Okay, so here are some examples. So if we have 8 plus 3, and hopefully, by the way, all of you have been typing stuff out in MATLAB as well, and I'm not going too fast. You should really be having MATLAB open if you can, so you can so you can learn this stuff better. It's tacit learning when you're actually doing something. So type out 8 plus 3 times 5. So I have 8 plus 3 times 5. If you press enter, that's 23. But if we really want to have 8 plus 3 as a group, and we want to evaluate that first, we need to enclose that in parentheses. So 8 plus 3 and times 5. So we're doing 8 plus 3 first, so 11, and times 5, you get 55. Okay, and then we just have some more examples. So the next one, I'll do 4 squared plus 5 divided by 4 times 2. So this is doing 4 squared. So we have 16 plus 5 divided by 4 times 2. So in this case, we want to make sure that we have 4 times 2 as a value that's in the denominator. So we need to enclose that in parentheses like that previous example I showed you. So if we press enter, then we get 16.625. Okay, so right now, I want to just edit that line of code that I just wrote. So I'm going to go up on the keyboard. Now I can access my history. So let's take a close look. So we see these 2 arrows here. No, so the space does not matter. So I kind of touched on this earlier, but I used this space to just make stuff easier to read. So I'll show you right now. But so I'm going to go up on the keyboard, press the up arrow. And then you see right next to these arrows, my most recent equation that I typed, that's displayed now. So I can keep going up and I can access stuff way back in the history. And I can go down, press the down arrow to go, to more recent stuff. So if I want to edit this equation now, I'm here. So I'm going to go through it all again. I just want to go very slow here. So I'm going to press up on the keyboard, and you'll see that this equation here is going to show up. So I'll press up. Now I can edit this equation by pressing on the left arrow key. So I'm going to do that now. And now I can move through this equation by using the left and right arrow keys. So I'm going to change this. I'm going to delete these parentheses. Now if I run this, we get a different answer. Because now what we really have is 4 squared, so 16 plus 5 divided by 4. So we have 16 plus 5 divided by 4. And then we have really 5 divided by 4 times 2. So hopefully that made sense. So in this case, I wrote it out here as well on the slides, but it's really treated as 5/4 multiplied by 2. Okay, so now I'm going to show you the space stuff. So if I go back to the equation that I just wrote and I delete the spaces here, I press enter, we get the same value. So again, I just like having spaces myself. It's up to you though. But I like having spaces between stuff like, the plus symbol, minus symbol, and division, multiplication, just to make it easier to read for me.
So it's basically like we can use the up arrow just to, like, if we have an equation that we wrote out, we can just use the up arrows just to go up and do it instead of us rewriting it over and over again, right?
Yeah.
Okay.
Because that would get pretty tiring, right? So you could just use the up arrow and then you would press the left arrow now, and then you could start editing that equation. Okay, so we're gonna go over one more example here. So we'll change it up, a bit. 2/3 raised to the power of, 3/2, and then plus 10. So we can do that, we get our answer. So for this first part, what we have is 2 raised to that fraction, 3 divided by 2. So I'm going to press the up arrow again because I want to change this equation. So up arrow and left arrow to edit the equation. If I deleted those parentheses and then I press enter, so you see my cursor is blinking here. That doesn't matter. I can press enter and that entire line is going to be computed. Okay, and then we get 14 this time. So now it's really doing 2 to the power of 3. It's not doing 2 to the power of 3/2. It's doing 2 to the power of 3, and then it's dividing that by 2. So you want to be careful with the order of precedence. And well, in this case, you would have to use parentheses, but in general, it's good to use parentheses to be explicit about what you want to do first. And then it also helps with the readability as well. Okay, so yeah, we have an exercise here now. So I want all of you to go into MATLAB. If you're not already there, you should be, but go into MATLAB and write this code yourself. So, this is the expression I want you to solve for, but you're going to have to write out MATLAB code yourself to find this answer, which is 53 divided by 5. So I'll give you a minute or two to write this out, and then I'll show you what the code should look like. If you have the slides, don't cheat. Don't look at the code yet. Try to write it out yourself. Okay, I'm gonna give you just a little more time. So one of the issues for me is virtually, doing this class virtually right now, is I can't walk around the class and make sure that everyone's already finished with this. So, and yes, you could tell me if you're done, but I want to be able to really know if everyone's already done or not. So I'm just gonna give you like, I don't know, 30 more seconds. Okay, so hopefully you've been able to compute that answer. So now we'll show you the code. So you should have had something like this. So what we wanted to do, in the first part here in the first line, we're doing 5 plus 2 plus 3/5. Now I put 2 plus 3/5 in parentheses because I want to evaluate that first. So in this case, we're pretty much typing out code that's almost exactly what we see in MATLAB. So we're doing A equals 5 plus. Now I want to evaluate this group in the parentheses first. So I use parentheses. 2 plus. And now since I have a fraction 3/5, I need to, well, I would choose to evaluate that in parentheses as well, just to make it easier to read. If I go back and I delete the parentheses for the fraction and I press enter, we're still going to get the same answer. And that's just because we have addition, so it's just being evaluated from left to right. So our answer would be the same here. Now we still have the parentheses enclosed around the group for 2 plus 3/5, but in this case, we didn't need to have parentheses around 3/5. Now if I delete all of the parentheses and then I press enter again, then it's still going to be the same answer. Because again, we're just evaluating this from left to right. So I didn't need to have all of these parentheses, and maybe you caught on to that as well. But here I think it's a good idea to do that. So also, so this says 7.6. So if I want to see this as a fraction, okay, that's not working. Okay, so this is explained a little differently. So there's a different command to, well, I guess it's a function to show this as a fraction. So I'm actually gonna look it up. I guess I forgot it.
Yeah, I actually tried seeing what 53/5 was in MATLAB to check my answer, and it came out exactly 3 higher than in the equation. It came out as 10.6 x flat, basically, instead of 7.6. No idea
So
why.
you typed out this equation in MATLAB, the same one?
Yeah, and then I typed out 53 divided by 5 afterward.
Oh,
Two different answers.
Okay, so let me go back here. Oh yeah, so we need to format rat, that's why. Okay, so we're going to format rat. And if I type in A, okay, so what's wrong here? We have, I'm going to type this all out again. Okay, so we have 38/5. So I guess I put this part wrong here. So I'm going to update that in the slides later on. But so sorry about that. But basically, yeah, so yeah, other of you caught on to that. So I'm going to update the slides, but the main point I wanted to get across was use parentheses to be explicit about the order of operation that you want to do in your MATLAB code. Okay, and then we have one more exercise here, so you can write this out as well. I just showed the code, but you can write this out in MATLAB and then see if you get this answer. And I'm going to double check that I actually had this one correct in MATLAB. So work on this one right now. I'll give you a few minutes and then we'll make sure that this code is correct. Oh, sorry. Okay, so here you go. You can see it now. Okay, so the fraction on the bottom is 20 divided by 3. I'm going to make this a bit bigger for you. All right, so I'm going to give you like, I don't know, 1 more minute, maybe a little less. All right, so I'm going to close out of this part now. Okay, and then we're going to go back into MATLAB here. Okay, so this time it actually is correct, the code that I have written out. So sorry about the first one. So this one again, I'm using parentheses basically all the time, just because for me it's easier to read it. So you see here, maybe it looks a little weird, but I have parentheses here. So these two parentheses, they're gonna basically denote the numerator for this first expression. Then I have 7/6 plus 2. So I want to basically enclose that. And then I have 7/6, that's enclosed in parentheses as well. Then we're just going to multiply that by 5/4 divided by 2. So you don't need to have parentheses on this last part here, though. But if we run that, then we get the correct answer this time. So I'm going to go back and I'll change the slide here to show what we actually had in class. I'll update that. So sorry about that mistake there. So anyway, so the main thing though, like I said earlier, is I want to, at least for me, I like using parentheses all the time to be explicit on what I want to evaluate first in my basically math expressions. Okay, So now we're going to talk about the assignment slash replacement operator. So we've kind of touched on this a little bit earlier as well. So basically the equal sign in MATLAB, it's an assignment operator. It's not as you would think about in a math class. So x equals 5, that's directly going to have or assign the value x equals 5. So we have x equals 5, and then we can replace that value with x equals 7 or something like that. And then what we have is on the left-hand side, we need to have a variable. So we need a variable like x equals 5. I can't do 5 equals x. So if I did 5 equals x, then yeah, that's not going to work. We need to have a variable on the left-hand side. And then in math, if you had something like x plus 2 equals 20, you could have that in math. That would be a valid expression. And then, you could do the basic math, and x should equal 18. So if I try to run this in MATLAB, again, that's not going to work. So we need to have just one variable on the left-hand side of the equal sign, where that's the assignment operator. Then we can have, values on the right. We can have more than one value if it's a math expression. So what we should do there is just x equals 18. Or we could have done, x equals 20 minus 2, and then x equals 18. So you just want to be careful with the equal sign, and try to not think, as you would in a math class, I guess, in that regard, because you need to have some variable on the left-hand side and then a value on the right-hand side. Okay, and then, so likewise, so I have one more thing here. So x equals 5 plus y. So right now, if I look on in the workspace, I have the variable x, and that's defined as 30. So now if I was going to try to rewrite this variable, I can do x equals 32. And now x is updated to the value of 32. If I did x equals 5 plus y, now that's not going to work because I don't have the variable y defined at all. So if I run that, it's going to say, yeah, there's no function that you defined called y, so I can't compute what you just put down. So make sure that if you have an expression here, that you already have all the variables defined. So if we want to write this out, x equals 5 plus y, and we don't know what y is yet, you can just assign some arbitrary value, like 1, because you can rewrite the value for y later on. So if I'm going to clear everything, so let's write down x equals 10. And then if I wanted to have some code like x equals, okay, I'll do z equals 10 plus y. So if I wanted to have this expression for whatever reason, like maybe it's a script or something, then I already need to define y at some point. So again, I can define some arbitrary value like y equals 1. And later on, I can do z equals 10 plus y. So that would give us, in this case, 11. But maybe at some point in a script again, and we'll talk about this later on, but maybe I have some expression that I can now calculate in the script that, y equals, I don't know, 20 squared. And then you can do, again, z equals 10 plus y. And now the value for z is 410. So the main point for this, though, is that I can assign a value to some variable, even if I don't know what that value should be yet, because I can overwrite that value later on in the script. Okay, any questions on that? So that'll be more helpful once we actually start writing scripts. Right now, it's, not very useful. Okay.
Professor, I have a quick question. I did the exact same thing you did, but for some reason I got as if y were still equal to 1.
Okay, so maybe you didn't clear your workspace, I'm guessing. So if you look at your workspace, what do you see there?
I see x is equal to 10, y is equal to 400, and z is equal to 11.
Okay, so maybe for this, take a picture of your screen or something, and then you can stay in the Zoom call after class, and then you can show it to me, and then I'll try to help you figure that out. Because you should see what I see too. So there's something happened there. Did you have this line here where y equals 20 squared? Yeah, you said y equaled 400, huh?
Yeah, I had that.
Okay. And yeah, someone's commenting, did you type z equals 10 plus y again?
I did.
You did or you didn't?
I did not. Let me see if
Okay.
that. Yeah, I got it. I forgot to retype it again.
Okay.
Thank you.
Yeah, thanks for pointing that out, Karen. Okay, so this right here is basically just what I talked about earlier on, what I just talked about. Okay, so this is just another really basic exercise. I'm sure all of you are going to get this. So if we have x equals 6, and then we have x equals x plus 3, then we have x equals 9. So then if I now type again, so I just rewrote that value. So x was 6, and now I did x equals x plus 3. So that's taking that value of x equals 6 that we just had, and then it's doing 6 plus 3, so x now equals 9. So now if I type x equals x minus 2, that's going to take our current value of x, which is 9, and it's going to do x equals 9 minus 2. So if I type in x here, x equals 7. Okay. So predefined constants, basically I just wanted to, show you this, but there's not much to go over here. So the for infinity, we're going to type that out as INF. And then, of course, we get 1 divided by 0. And then pi, if we want to use that, we're just going to write pi. Not a number. So this will be something that you see more. Yeah, you see the usefulness of the semicolon. Yeah, it can get pretty cluttered if you don't use it. So NaN, that means not a number. So we're going to see that more often once we start importing data. So we're going to get to this in, I think, chapter 3. So if I click on import data on the home tab, I don't have any spreadsheets, that I prepared for this class, but basically you click on that, then you can pull up a spreadsheet, and sometimes you will have like a column of data, and at the top you might have some, I don't know, maybe it's a column for stress or something. If you have a cell where there's nothing in there, you're gonna have it say not a number. So that's just what NaN means. So you'll see that again once we start importing stuff into MATLAB. And then the imaginary number, that's just going to be I or j. Okay, so formatting commands. I'm not going to actually, type this out in MATLAB. This is more just for your knowledge here. So you have a lot of different expressions that we can write to format stuff. So you saw me earlier do format rat, and so yeah, I forgot that command for a second earlier, but when you format rat, that just is going to display our math as a fraction instead of as a decimal. And then we have, so the most often used expressions here are probably format short and format long. So if you're, again, I want to give you guys context for what you're going to be doing here in college. So if you're working on a lab report later on, sometimes you want to do format short so you don't have a ton of these decimals at the end. So that's probably one you're going to use in format rat as well. But something you'll just use sometimes. Okay, and then we have trig functions. So we're almost out of time, but we'll go over trig functions at least. Okay, so just like with math, with the math operators that we discussed earlier, trig functions, they're going to be, pretty much as you would expect. So it's clear. So for trig functions, you need to make sure that you have the argument enclosed in parentheses. So when we're writing out decimal format, so I think there's a way to reset the format. So I don't remember that on the top of my head. If I need to format decimal, maybe that's it. No, it's not. So if you type help and then format like I just did, either format short or format long. So, okay, someone answered that. But if you have a function that you want to look at more documentation, you can either use a Google search to look it up, or you can just do help and then whatever that function is. Or you can do it for a command too. So I just typed help format, and then we see all of the stuff here for format. Okay, so I'm just going to clear this out now. So, okay, so I was saying for math, when we just are like writing it out, sometimes we just write it out like sine x, but in MATLAB, we need to be sure that we actually enclose that in parentheses. So sine of x. In this case, I already had x assigned to 7. Okay, so I don't have any. Oh yeah, so by default, trig functions in MATLAB, they're in radians and not degrees. So if I want to evaluate sine of x, but this time in degrees, I'm going to type sine, then d of x. So sine d of x, the d that's just, standing for degrees. Okay, so we'll do this exercise right here first, and then we'll probably end it for the day, or we have 2 more slides after this one, so we'll try to do that. So if I have x equals pi, so I guess I can actually change this to format short now. So if I type in x, then we get the decimal. Okay, so if I did a equals sine of x, so it's in radians right now, then we get, so you see we have this value here. It's not exactly 0. And the case for that, or why that's the case really, MATLAB uses what they call is floating arithmetic, which isn't exact. So this is very close to 0, but you're not going to get 0 exactly. But for engineering, basically this is close enough to 0 where we can say sine of pi is 0. Okay, so now let's say y equals 90. So we'll pretend that that's 90 degrees. So if I want to evaluate this for sine of d, so again, if y equals 90 degrees and I want to evaluate sine of y in degrees, I do sine d and then b equals 1. So another thing, if we want to be more compact, I can just do sine, or c equals sine d. This time I can just write something like 180 degrees. So in this case, I'm not assigning a variable to 180, but if I just wanted to evaluate sine of 180 degrees, I can just write this line of code here. So if I press enter, then c equals 0. Okay, and that should be it. Basically, this is just some other common functions, but it's 11:15 now, so that's pretty much it. So if you guys have any questions, then feel free to stay here on the call. And on Monday, we're going to start going over arrays. So no homework yet, but I'm probably going to assign homework sometime next week. Okay, so that's all I got. So I'll see you guys on Monday. And again, I'll stay here for a few minutes for any questions that you might have.
Okay, thank you, Professor. Have a good day.
Yep, have a good weekend, guys.
Thank you, Professor. See you next week.
See ya.
Professor, so if I go back to like on Canvas or on the Cal State Fulton's homepage, if I wanted to like just the add-on and stuff, it shouldn't affect me in the class, right? I won't like be dropped in the class, or is it more just the book only?
If you do what?
So so the email I sent you about
Oh yeah, I forgot
the
to talk about that
email.
too, huh? I'll put an announcement. Okay, but yeah, go ahead.
I was just curious because this is a new thing. I'm just curious. Is it more just going towards the book? Like if I'll get like refunded my money back, or with the book, or I won't be like dropped
Yeah, you're not
class.
going to be dropped,
Okay.
And hopefully you weren't charged yet. I didn't see the date on that, but yeah, you can opt out of getting the book, and yeah,
Okay.
you're still going to be in the class. Yeah.
Okay. Just making sure.
Hmm.
Thank you.
Yeah.
Professor, I want to ask, are these slides they have on the bottom right, are they posted on Canvas? Like say like we want to review or something?
Yeah, it's on Canvas right now, so I need to update that one mistake I had on the slide earlier. But so I'm showing you the home page right now. So then if I click on week 1, then I have the slides posted on the top here.
Okay. And then also, when we use MATLAB, is it better to have it like when you were doing the problems for I think earlier you're doing some problems for the variables. It came up on your screen as fractions. Is it better to have them like as a fraction or just as like a decimal?
I usually have them in decimal format. I mean, you could probably tell I didn't even remember what to do to format it to fractions, but it doesn't really matter.
Okay.
Yeah, I mean, we're not going to be doing, too many things in this class where it should or shouldn't be either in a fraction format or decimal format.
Okay. Thank you.
Mm-hmm. Okay, does anyone else have any questions?